The Theory of Political Economy by William Stanley Jevons. Chapter 3 Theory of Utility Part 11 Distribution of a Commodity in Time. We have seen that when a commodity is capable of being used for different purposes, definite principles regulate its application to those purposes. A similar question arises when a stock of commodity is in hand and must be expanded over a certain interval of time, more or less definite. The science of economics must point out the mode of consuming it to the greatest advantage, that is, with a maximum result of utility. If we reckon all future pleasures and pains as if they were present, the solution will be the same as in the case of different uses. If a commodity has to be distributed over n days' use, and V1, V2, etc. be the final degrees of utility on each day's consumption, then we ought clearly to have V1 equals V2 equals V3 equals Vn. It may, however, be uncertain during how many days we may acquire the stock to last. The commodity might be of perishable nature, so that if we were to keep some of it for 10 days, it might become unserviceable and its utility be sacrificed. Assuming that we can estimate more or less exactly the probability of its remaining good, let P1, P2, P3, P10 be these probabilities. Then, on the principles that a future pleasure or pain must be reduced in proportion to its want of certainty, we have the equations V1P1 equals V2P2 equals V10P10. The general result is that as the probability is less, the commodity assigned to each day is less, so that V, its final degree of utility, will be greater. So far we have taken no account of the varying influence of an event according to its propinquity or remoteness. The distribution of commodity described is that which should be made and would be made by being a perfect good sense and foresight. To secure a maximum benefit in life, all future benefits, all future pleasures or pains should act upon us with the same force as if they were present, allowance being made for their uncertainty. The factor expressing the effect of remoteness should, in short, always be unity, so that time should have no influence. But no human mind is constituted in this perfect way. A future feeling is always less influential than a present one. To take this fact into account, let Q1, Q2, Q3, etc. be the undetermined fractions which express the ratios of the present pleasures or pains to those future ones from whose anticipation they arise. Having a stock of commodity in hand, our tendency will be to distribute it so that the following equation will hold true. V1P1Q1 equals V2P2Q2 equals V3P3Q3 equals VNPNQN. It will be an obvious consequence of these equations that less commodity will be assigned to future days in some proportion to the intervening time. An illustrative problem involving questions of prospective utility and probability is found in the case of a vessel at sea, which is insufficiently victualled for the probable length of the voyage to the nearest port. The actual length of the voyage depends on the winds and must be uncertain, but we may suppose that it will almost certainly last 10 days or more, but not more than 30 days. It is apparent that if the food were divided into 30 equal parts, partial famine and suffering would be certainly endured for the first 10 days to ward off later evils, which may not be encountered. To consume 1/10 part of the food on each of the first 10 days would be still worse, as almost certainly entailing starvation on the following days. To determine the most beneficial distribution of food, we should require to know the probability of each day between the 10th and 30th days forming part of the voyage, and also the law of variation of the degree of utility of food. The whole stock ought then to be divided into 30 portions allotted to each of the 30 days, and such magnitudes that final degrees of utility multiplied by the probabilities may be equal. Thus let V1, V2, Vt, etc. to be the final degrees of utility of the first, second, third, and other days supplied, and P1, P2, P3, etc. the probabilities that the days in question will form part of the voyage. Then we ought to have P1 V1, P2 V2, P3 V3 equal P29 V29 equal P30 V30. If If these equations did not hold true, it would be beneficial to transfer a small portion from one lot to some other lot. As the voyage is supposed certainly to last the first 10 days, we have P1 equals P2 equals P10 equals 1. Hence we must have V1 equals V2 equals V10. That is to say, the allotments to the first 10 days should be equal. They should afterwards decrease according to some regular law, for as the probability decreases the final degree of utility should increase in inverse proportion.